Here is your lesson on factors, prime numbers, and composite numbers, everybody. So definition here, product, you should know what a product is, but an answer to a multiplication problem. 7 times 8 is 56. 56 is the product. 7 and 8 are considered factors. Okay, let's answer this question. What is a factor? A factor is all the whole numbers that can be evenly divided into another number. Factor by using a factor table. I like to use a table where we put the pairs together, and you'll know what I mean when I start doing it. But a factor table seems to be a nice thorough way of doing these problems. So let's go ahead and start factoring 36. And I always say start with 1. Okay, so 1 and 36. So that is a factor pair. 2 and 18. 3 and 12. So you'll notice on this side of my factor table, I started with 1 and I keep going up. I keep going up, 1 to 2 to 3, and I'm testing to see if it's a factor. I'll go to 4 now. 4 and 9 is a factor pair. Is 5 a factor? Nope. So let's skip 5 and go to 6. 6 and 6 is a factor pair because it's a square number. 6 times 6. So factors in this problem are 1, 2, 3, 4, 6, 9, 12, 18, and 36. Now these are all called factor pairs. They all, if you were to multiply them, make 36. 1 times 36 is 36, of course. 4 times 9 is 36. 3 times 12 is 36. Now here's a nice organized list of all the factors of 36. You might make a little mental note here. I did not list 6 twice, even though 6 is written twice here. If I'm merely just writing the factors down, I'm only going to list it once. Okay, let's go through some factors of 48. And let's start with 1. 1 is always a good place to start. 1 and 48 is a factor pair. 2 and 24. 2 times 24 is 48. 3 divides into 48 16 times. That might not be totally natural to you, but the divisibility rule for 48 is that you add up the digits. 4 plus 8 is 12. And does 12 divide by 3? It does. That's a rule for 3 and 9. That rule does not work for other numbers like 5 or 6 or 10. But the rule for 3 is you add up the numbers in the digits. The rule for 3 is you add up the digits in the number. So 4 plus 8. Let's keep going here. 3 times 16 worked. 4 times 12. That's a factor pair. Does 5 divide into 48? No, it does not. 6 will. 6 times 8. And you'll notice here, as you're going down the line, that the numbers are getting closer and closer together. 1 and 48 are far apart. 2 and 24 a little closer. 3 and 16 getting really close. 4 and 12, 6 and 8. And that's about as close as the factors are going to get with 48. Because the only factor in between 6 and 8 is 7. But 7 is not a factor of 48. 7 times 7 is 49. So don't confuse that with it being a factor of 48. That would not work. So here again, here's a formal list of all the factors of 48. You're going to want to probably do that. Some people just say, well, these are all the factors of 48. That's a common confused idea, but the factors of 48 are all the numbers. Okay, so let's go ahead and go into what a prime number is. A prime number is a number that is only divisible by 2 factors. That's it. Itself and 1. That's it. Take 37 among many, 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 many numbers that are prime is only divisible by 1 and 37. That is the only factor pair that I can think of that make 37. Now you might be able to think of other numbers that make 37 when you multiply them, but they have to be whole numbers. So you can't use, for instance, you can't use 1/2 and you can't use 1/2 and 74, even though that does make 37. That's not allowed. You can't do that. So 1 and 37, that's it. If I'm going down the line, 2 does not divide into 37 because it's even. 3 does not divide into 37 because 3 plus 7 is 10. 3 does not divide into 10. 4 does not. 4 only goes in even numbers too, even though that wasn't a rule we discussed in class. 5 does not because it doesn't end in a 0 or a 5. 6 will not because 2 and 3 don't work. 7 does not because 7 divides into 35 and 42, but not 37. 8 does not, so I can go down the line. I won't keep going here, but that's what you want to do. You want to keep checking numbers, 7, 8, 9, see if they work. And if they don't work, then you can consider it prime. But make sure you do your mental work there. Make sure you see if it works out. Here's a list of prime numbers. 2, 3, 5, 7, so on and so forth. You might want to jot those down. You should understand that prime numbers are infinite. They go on forever. So there's no end to the number of prime numbers there are. They just go on and on and on. But I would say these smaller ones, down here, are pretty important. You're going to need to know those, especially when you get into dividing fractions and telling whether it's in simplest form or not. Now, since we have prime numbers, well, we have to have something that is the opposite of that. Now, the opposite of a prime number is a composite number. A composite number has more than 2 factors. It has 3 or more. That's how many factors it has. Take 25, for instance. 25, you might think is prime, but yes, it has 1 and 25. 2 does not divide into it. It's not even. 2 does not work. 3 does not divide into it. 3 divides into 24, but not 25. 4 does not divide into it, but 5 does. So 5 and 5. So the only factors of 25 are 1, 5, and 25. So this is the smallest number of factors that a number can have and be considered composite. Most numbers have 4 or more, but this number is kind of special because it has 3, because it's odd and it's a perfect square, and you have that 5 in there. This has more than 2. If it's prime, it only has 2. That's it, just 2, no more. Here's some examples of composite numbers, and like I said, they just go on and on and on and on. Now, one thing that you may or may not know is that the number 1 is kind of special. It doesn't fit in either category. It's not prime, and it's not composite. It's neither of those two. In order for something to be prime, it has to have 2 factors. Now, if I were to factor out the number 1, well, 1 has itself, and that's it. If I were to list out the factors of 1, there's your solution set. That's only 1 factor. So you can't call it prime because a prime number has 2 factors, and you cannot call it composite because it doesn't have more than 2 factors. So it's neither. It's neither prime, it's neither composite, it's none of the above. So it doesn't fit in either category.